And the last property of water we want to talk about here is the fact that ice can float. So we want to talk about states of matter. You've learned in your previous classes about solid, liquid, and gas phases. Okay, and for most substances, the solid phase is most dense. Okay, but with water, it's a unique property here. Water is more dense as a liquid than it is as a solid, and that's because of the hydrogen bonds. So take a look at this diagram down here. Look at the liquid water. Each of these little red dots with the white dots attached to it, that represents a water molecule. You see how close the hydrogen bonds are between the water molecules? They're very condensed, and so we get more water molecules into the same amount of space. So that makes it heavier, okay? It has a higher density. But when we look at ice, as water freezes, those bonds stretch from each other and they push each other away while still maintaining bonded. Now look at all this space that has occurred here. So this is the same number of water molecules as in the liquid water, but look at how far apart they are. They're more spacious. Because of all that extra space, the ice is going to weigh less, okay? It's going to have a lower density, and that is the reason why ice floats. So why is that important? Well, a majority of our Earth is covered in water, and a lot of the times there are seasons where we will receive freezing conditions. So why doesn't an entire lake, for example, freeze, during the winter? Well, the reason is because of the fact that when our lakes reach freezing temperatures, as water freezes, it floats to the surface. And then this creates sort of like a shield over the surface of the lake, right? When lakes freeze over like this, it stays very cold here, but that acts to insulate or keep warm the rest of the water. So that is why fish don't die in the winter and other marine organisms. They are able to live because the water is being insulated by that layer of ice that's on top. So the ice parts of water are going to float, and then the rest of the water underneath, the temperature is going to be a little bit warmer because of the insulating effect from that ice cap on top. The last thing we want to talk about is that water can break down itself too. In any substance, water can fall apart into two pieces. This side here, this is called a hydroxide ion. And this over here, this is a hydrogen ion. And we're going to focus on the hydrogen ions because the amount of hydrogen ions something has is a way that we measure its pH value. Okay, and I'm sure you've heard of pH before. Here's a picture of the scale. The pH value goes from 0 to 14. And right smack dab in the middle, a pH of 7 is pure water. So pure water has a complete balance in its hydrogen ion concentration. If you start adding more hydrogen ions to something, okay, like, looking at tomatoes here, then it becomes more acidic. So anything below 7 would be considered an acid. That is going to cause the pH number to go lower, even though the hydrogen ion concentration is increasing, right? So here, when you look at this diagram, you see our hydrogen ion concentration here. Okay, notice the negative numbers on the powers of 10. So we're getting more hydrogen ions as we move this way on the pH scale. But look at the direction that we're going. Our pH value is decreasing as our hydrogen ion content increases. So something like your stomach acid or lemon juice, those are examples of acids. Okay? On the other end of the scale, if we go above 7, then they're going to have fewer hydrogen ions. So very low concentrations of hydrogen ions here, right? Because these are negative powers of 10, which means the number's getting smaller and smaller and smaller. Those are going to be bases or basic solutions. And a good example of that, baking soda or bleach. So it's important that you understand how we measure pH on a scale from 0 to 14. Each number represents the hydrogen ion concentration. And the relationship you want to get from this is that as the hydrogen ion concentration increases, the pH value goes down. The number goes down. So the highest that you can have hydrogen ion concentration will have a pH of 0. The lowest hydrogen ion concentration will have a pH of 14. Okay, so it's an inverse relationship. Okay, so that's the lecture on water. Again, make sure you check out those objectives, and if you have any questions, please feel free to ask in class.